Hi everyone, welcome to Observability Guru. Today we are very excited to have a one of a kind session where we have been joined by Andy Grabner, who is a pioneer, I would say, from based out of Dynatrace, where he's been spent long time in Dynatrace, shaping up the observability world, and he's also a CNCF ambassador. And if you have look into his LinkedIn, like he's almost everywhere, maybe traveling in Europe, sharing his knowledge, experience. He also been partner with his few of his colleagues to write some awesome book. So today we're going to discuss about this cloud native observability, latest book he has written, and also his concepts about observability, how it is evolving, and those things. So again, Andy, thank you so much. Thanks for taking time from your busy schedule. And just to start, do you want to give a quick intro about yourself to our audience?
Yeah, sure. Thank you so much for having me. It's great to be part of the Observability Guru podcast. And yeah, as you said, I've been in observability for a little over 18 years now. I started my career even before that. I did load and performance testing for about 8 years. And even before that, I did 2 years in a different software company. I have a software engineering background, but very quickly went into performance engineering. And for the last 18 years, observability. So at Dynatrace, maybe many people know it, but for those that don't know, we are an observability intelligence platform, as we call it. And obviously, the industry has reinvented itself multiple times from monitoring and APM to observability, and now everything around AI. In my role, I think for me, I have the best job in the world because my mission is to create a global fan base for observability. And I say observability and not Dynatrace because I try to be broader than just what we do as an organization, really sharing best practices, learning. And I'm also very fortunate to be a CNCF ambassador. So that's the Cloud Native Computing Foundation. And also working very closely with the product teams around OpenTelemetry, OpenFeature, Captain, and others. Yeah.
That's great. I love that when you say observability fan base across the globe, which sounds like really cool, and that's what we want to do as well. So Andy, like tell us like a strange question, probably 18 years back, right? When you start your career at Dynatrace, what you were thinking, right? Probably, I think you came from a development background, performance background, and so like how you turn in how you started your career at Dynatrace and how you felt it at back then.
Yeah. So one of the things that made it very easy, I knew our founder and CTO from my previous job because in the previous job we did performance engineering, so we created performance testing tools, load testing tools. The tool back then was called Silk Performer, which was bought eventually by Borland and then Micro Focus and all that stuff. But basically, we did performance testing, right? And performance testing is all about injecting load or simulating load against an application. And then from a load testing tool perspective, you could figure out at which time is the application getting slower, at which time do you start errors, to see errors. We had limited visibility into the app. We could only look at CPU, memory, network, right? That was limited. And so when our founder from Dynatrace burned, when we were still working together there at the load testing company, he eventually had the idea and saying he wants to solve the problem that we're testing against the black box. He wanted to convert that black box into something we can see into. And then he founded Dynatrace, and we were one of the first companies who were providing automated end-to-end distributed tracing in first Java-based applications and then .NET-based applications. And because he knew me from the work with performance engineering, and I also did a lot of educational stuff there, he said if I would like to join Dynatrace and basically educate the world about what we back then called APM, Application Performance Monitoring. And so that's why I joined Dynatrace. And I also had to learn a lot, obviously. I have my performance engineering background, but observability, traces, logs, metrics, these were all still also new things for me. And then we did a lot of analytics. We did a lot of workshops with our customers and learned why systems break, what were the most common problems. And then I tried to convert the lessons learned into blogs to educate the market around what are most common things we see in distributed applications that make them fail based on observability data. And so this was the start. And then from there, 18 years later, I feel I still do similar things. The technology has obviously changed. The types of applications, the architectures have changed. But essentially, we're still trying to do similar things. We are trying to help people, making sure that the software and services that they build, that they test, that they deploy and operate, that they are healthy, both from a business perspective, healthy, that they're delivering business value, but also from a performance and resiliency perspective.
That's great. And back to Dynatrace, right? Like when probably like long time back when I heard Dynatrace, and one thing it just clicked me is this one agent, right? Since you have always one agent which will do the magic, right? So how that started, like, and what do you feel about like how Dynatrace evolved from back then to now? Because I see like in my career looking at observability tools and especially Dynatrace is a great way to figure out where the industry is heading, right? Because these companies always jump into the new thing. They develop the observability around that. So example, when we are back then on-prem, we move into cloud, and then it was cloud native, and then now we are into AI. So it's like, how we monitor AI, how we monitor all the GPUs. And so how is that experience?
Yeah. So if I go all the way back in the early days, we had a Java agent, we had a .NET agent. So we had individual agents that you had to manually load into your process. And what this means, I give you an example from Java. You had to modify, as an end user, you had to modify the startup parameters of Java and add a command line parameter to load our agent. That agent then did the instrumentation, and you had to do this for every single process. So that means you had to touch the deployment because you had to modify it slightly. And then the idea of the one agent, right? We have now for many years now, I think at least 10, 12 years, we have a single agent. We call it one agent.
Yeah.
The idea is you install it on a machine and it automatically detects everything on that machine. It automatically injects itself into the process. I mean, now talking about this now in 2026 maybe sounds not as exciting anymore. But when we did this as the first time, right, in the industry, it is magic. It felt like magic. It still is magic because we're doing quite a lot of things. We're basically taking away the pain for any engineers to enable observability, to get automated logs, metrics, traces, events, without having to think about which technology this process is, without having to think about what are relevant instrumentation points. So we have 20 years now overall in Dynatrace experience in building agents to automatically instrument the right things. And I say the right things because instrumentation is not easy. It's easy to instrument, but it's not easy to instrument the right things and capturing the right things. Right. And I think, that's the one agent. But I mean, the world has changed, obviously, right? Now the world is very rightfully so pushing towards open standards, and we have OpenTelemetry as an open standard from a protocol perspective, meaning how do we capture a log, a metric, and a trace. And we also see in the OpenTelemetry community, obviously now the move towards more and more automated instrumentation. So most of the major languages that are supported by OpenTelemetry, they have an auto instrumentation agent because instrumentation is not easy, and so providing it automated makes sense. And I know there are also efforts now going on to kind of rebuild something that the one agent is doing. So it's interesting. So I think we've been there 10, 12, 15 years ago. We've done this already, and now the global community is basically building or trying to replicate what we've built many, many years ago.
Absolutely. And just like sharing my experience with some of the teams I had to work with, one thing they loved is that you don't have to configure a lot of traps, right? Because Dynatrace one agent will figure out that baseline performance and then inform you, right? So it's not that like when something happened, client asks you why you missed it, say, okay, that's just one trap we missed, right? Maybe we'll do audit, we'll configure. So it's kind of like saving a lot of people, I would say. So Andy, like one thing, right? When I'm going through your book, and AIOps is a major thing, right? I mean, it started maybe around 2016 when Gardner said that's going to where our world is going to head. But it took around 5-6 years after that, right, to the companies to really embrace it. And what I feel like is when it comes to AI ops, there are use cases like anomaly detection and maybe forecasting, and then the correlations, intelligent root causes. And now everyone is talking about these things now, right? And say, okay, yeah, that's great. We are using AI, but I think you guys are the pioneers, right? Like I remember Dynatrace used to have almost everything like few years back, right? Five, 6 years back. Yeah.
True.
So
Yeah, no.
what was that experience when everyone comes and tells you AI ops and you have been involved in this for last several years?
Yeah, I mean, on the one side, you could see it as to be flattered if people like Gartner or companies like organizations like Gartner say, and even give it a term, and you have already implemented it. So maybe this is a good thing, right? But in all seriousness, I think it is, as you said, it's really interesting to see that the industry overall is implementing and talking about things and implementing things that we have thought about and implemented many, many years ago. But the question is, why wasn't it more successful from the start? And I think the reason is that while I also want to be fair to our competitors. I think there's great other observability products out there that also do a good job in automated baselining, in root cause analysis. So we're not the only one, but I think we definitely have done pioneer work, and I think we have definitely an advantage in many areas. But the biggest challenge with large enterprises that I see is that they have many different observability approaches, meaning different applications, different environments, different teams use their own different tools. It's very common. I just came in from Canada. I spent a week there, and I was at KCD, Kubernetes Community Days, and we also had the Dynatrace event. And talking with these large organizations, they all say, hey, we have about 5, 10, 15 different tools for observability, right? I remember I was on stage with Autodesk at our conference. They were saying earlier this year they used to have 5 different tools alone for just analyzing distributed traces, right? And you think, wow, if you have that many different tools, that means you have many different data silos. So you have some data here, some data here. Probably you have duplicated data, right? Because if you're using different tools for different levels of the stack. And so this actually makes then the promise of AI ops very hard, because the promise of AI ops is that you're using baselining and anomaly detection and root cause detection in a very complex environment. But if this complex environment is monitored with different tools, with different data formats, with different standards, with different level of granularity, it's also for a tool and also for an AI not that easy to understand if a problem that happens up here is actually the root cause is down here, right? If you have many different hoops in the middle. And so, and as of today, this is, I think, still a challenge for organizations that have a complete diverse set of tools and ways to do observability. I mean, that's good news, right? I think more and more people, more and more organizations are understanding that this is an issue. They're consolidating, they're standardizing. So many organizations standardize either on a single vendor like Dynatrace, or they're standardizing on a single protocol like OpenTelemetry, and then make sure that the backend is also standardized. And I think we're getting closer to that promise. And in the book, we talked a lot about the building blocks to get there. Yeah.
Absolutely. So I think like it's time to jump into the book, right? This, so what I want trying to get you at is a place where some of these things, right? AI ops use cases has been around for last 5 years, right? And so you raise a good point, like just to understand what has changed. So why now everyone is more into AI? They want to bring AI into their ecosystem. And I was just thinking, right? It just hit me, right? Probably for you, like maybe you can also relate to maybe when you start, right? Maybe like initially first 5 years, it was all about availability, right? Everyone was so focused. My systems has to be available. And then after that, like, it's all about availability is given, cloud is there, you have a lot of resilience architectures. So it was like latency, right? Like, within micro milliseconds, can you respond? And if you can't respond, then it as good as outage, right? But now I think last 2 years things have changed. It doesn't matter that your application is responding fast, but is it responding the correct thing, right? Because I heard like a couple of weeks back, I think one of the big companies, they have created a AI agent, a chatbot wrapping a frontier model, and then someone was ordering while they were using it to solve their Python problem, right? So so it because like they would have roll it out very quickly, so they would have not handled all those edge cases, right? So idea is that even though that chatbot is working fine, responding fast, but it's not doing something which is supposed to do, right? I think with AI introducing this unknown, right, probability, right? We are moving from determinist to probabilistic approach, and it has created so much challenge, right? So is that what you've seen and which led you to write this book, or how you overall interpret this change?
Very good question. I think I have a slightly different opinion. I think in the last it's not in the last 2 years that we are focusing on that an application does the right thing. I think we've always done this, because otherwise, if you think about all of the banking systems, healthcare systems, they all had to work correctly. They all had to provide APIs that not only had to be available fast, but also accurate. That means because, before AI, somebody could still hijack an API endpoint, maybe do some SQL injection, maybe exploit a bug, and therefore do something with the system that it was not supposed to do. Nowadays, it's obviously very interesting to see AI and AIs go off and exploit at a completely different scale problems, or some people are very creative. Like I also remember these postings when somebody ordered a burrito and then they were solving the coding problems. It just shows that we have a new technology, but not only a new technology. I think we also have a new generation of software engineers coming in. And I think every generation new needs to learn the trade of real software engineering. Software engineering is not just about writing a line of code. Software engineering starts with good requirements definitions. And the requirement definition, just as you said, it must not only include what is the happy case, so what is this thing supposed to do. It also has to include guardrails. What is it not supposed to do? What are the edge cases? It also needs to have, and this is also what we do in the book, right? In the book, we talk a lot about observability-driven development. As an engineer, when you write a new piece of software, a service, a function, a feature, I think it's very important to define two things. What is the definition of success from a business perspective? And what is the definition of health from a technical perspective? And to give you an idea or an example, if we have an existing piece of software and we're writing a new feature, let's assume in Dynatrace, we are writing a new feature, a new chart visualization. Okay, somebody says this is what it is. Yeah. So when we develop this new feature to visualize data in a new way, we need to define the success criteria from a business perspective. We are expecting that maybe 10%, 20, 30% of our users will adopt this feature within the first month, within the first year. And then there should be continuous usage of it, because otherwise it's a feature that we built, but it doesn't bring us business value. On the other side, we need to define technical health indicators. Technical health indicator could mean if somebody uses this chart, it needs to render within 500 milliseconds for a certain type of data set, right? Because otherwise it's technically not healthy, because nobody will use it, right, if it's too slow. Yeah. And I think this is something that I believe every generation of software engineers that come in, we all need to relearn this. We need to make sure that the next generation, and now the agents, understand this as well. So that means software engineering is not about writing nice looking code. It's about starting very early with a clear definition of what you want, what is the business impact and how do you measure it, the business success, and what is the technical way, the technical health, and how we can measure it. Also the guardrails, I think, is very important. So to avoid something that somebody can exploit a chat and have it solve Python problems when it should actually just take a meal order. Yeah.
Yeah. And just to continue on that, I think in the book, right? Like I think you and your co-authors, one of the first point you guys are trying to bring is that there's a difference between monitoring and observability, right? And I think that that's kind of like first attempt, like you are trying to bring in to say, okay, monitoring is different, observability is different, and on top of that, you have to think about your business, right? And business resiliency, business ROI, right? So how should the team approach, right? Like in this day and age, right? They have a native AI-based application, and when they look at this monitoring and observability, what is your view, right?
Yeah, I think the view is, I think just a little bit repeating what I said is, a piece of software is no longer just healthy when the CPU is healthy. It's no longer just healthy when your response time is healthy. It is healthy if you're actually having end users that leverage this particular piece of software, or you have somebody that leverages that API. So I think the business aspect is very important, but then tying it to, I always refer to them to technical leading indicators. Again, these health metrics, these technical health metrics. And then the other thing, what is changing, or what has changed, we're talking about different scale, right? I mean, I'm sure you had many different podcasts and discussions reciting that we went from monoliths to microservices to cloud native architectures, where we write a little bit of our code and we are leveraging a lot of cloud native technologies or services. So we have a lot of very complex systems, and we need to understand what every piece of the system does. This is where in the book we also write a lot about context. Context is king, meaning when you are monitoring a system, when you're monitoring a service, you need to know what is this service, in which version does it run, where does it run, who owns it, what are the business requirements, what are the technical requirements, what are the dependencies, right? Are there very tight dependencies? Are there loosely coupled dependencies with other components? Because all of this information is needed if something starts to not work as expected. Then you need to know the full end-to-end chain. You need to know exactly what components are involved. It's like if you have ever played domino, right? You need to know which of the domino stones is the one that has started the whole thing, which is the one that is the weakest link. And I think this is why this is very important. So different scale, and we need the metadata, and we need to have the definition of what is the expectation to this service, what is the technical health, and then where does this run, what's the underlying thing, and what are the connections to other systems.
Yeah, and what I have seen is that, right, when teams is starting developing their products, they have some idea, like what is good mean for them, but idea is that, like it's just they just focus on that good, and then probably they just go on to build a product, but then after that only they realize, can I measure it, right? So some of the things you mentioned about the loading times, the response time, can we measure it, right? And one of the problem is not treating observability as a first class citizen, right? I think that's something I heard, like I heard, like you mentioned in some of the podcasts, and even the book probably is maintaining that, right? So why you think it's not happening? Like, why is observability is not a key thing when they start development, and why you still have to tell that, like think about observability, think about all those things upfront?
It's a good question. I think it's changing a little bit now. I think there's more awareness about observability, but I had my first job in the 90s. And if I think back in the 90s as a software engineer, I did not want to write any tests, even though 10 years later, test-driven development made a lot of sense to me. And it took me a long, long time. It took the industry a long, long time to adopt best practices like test-driven development. And this is why I think we see something similar with observability. That's why observability-driven development for me, and we explain it in the book, it's really about thinking first, what are the indicators, the metrics, the logs, the traces, the business insights that I need to understand if that component runs healthy. And when I know what I need, how can I collect this information? How can I make sure when I collect this information, these logs, these metrics, these traces are enriched enough with metadata so that when not only my observability for my service, but all the other 10,000 microservices are also sending data to a central place, that it's still understood where this data comes from, what it means, what is the expected values or value range, and how is everything connected. Because if something starts to fail over, you need to understand in this complex system that we live and that we're building here, where to go next to find the root cause. Yeah? And also see if something starts failing, you can also then predict. This is where forecasting and predictions come in. If you start to see one of the services start to get slower, start to fail, you can immediately predict what impact will this have upstream, because you know your dependencies and things like that. But yeah, to your point, I think it's similar to test-driven development. It took a long time to educate software engineers that test-driven development is a thing. Nowadays, I don't think we need to argue anymore about this, but it's similar to observability-driven development. I have a big hope that with agents and agentic coding, that if we have the right skills, if we define skills for an agent, that the agents will make sure to ask questions before they start coding. Hey, how do we measure the health? How do we measure the business? Do you want me to add observability to it?
Yeah, and just continuing that, I think one point that you guys are trying to make in that book is like follow a standard, right? Standardization is very important, and it's not only our component, but maybe the downstream systems, upstream systems, right? Like we all following that the same standard. And when it comes to standard, like you are part of CNCF, you guys like the OpenTelemetry is one of its biggest project. So are you happy with its adoption?
I am. Yeah, I am. I mean, it's still ways to go, but just this week, I think it was Wednesday morning, OpenTelemetry graduated. So if you're familiar with the CNCF, these projects go from to different stages, from sandbox to incubating and now graduating. And OpenTelemetry has reached the highest status, which means adoption across the industry, broad adoption, and very solid community, active contributions. And I would say half of the conversations I had this week alone in these different events, the KCD events and also the Dynatrace events, OpenTelemetry is always somewhere there. Yeah. So, I mean, it will still take until it's fully adopted, right? Because there's a lot of existing software out there, a lot of, we call it legacy software, that might not be changed just to ingest or to integrate OpenTelemetry. This is where agents come in, either an OpenTelemetry auto instrumentation agent or like a one agent we have from Dynatrace. But the future is we'll see more and more OpenTelemetry adoption out of the box, because it's the established standard, and this is just what we will get.
Yeah, and I'll ask you a question, right? Which is kind of like a little bit outside something I wanted to ask you. No, I think like you familiar Traceloop, right? They came up with this open LLM telemetry, which I think Dynatrace is also supporting, right? Like we and do you see a competition, or like I know like it's an implementation on top of open telemetry, but it's like one fine time, like it will come merge and be a
it comes. It comes. I think that everything is already in motion. There's already discussions that while we had like kind of separate standards on top of OpenTelemetry, now there's a new working group that will define the semantic conventions for AI observability underneath OpenTelemetry. That's what's happening right now.
Yeah. And so why it is important is, I think you like because one of the important thing is observability is not just enabling metric logs and traces and events, right? I think in the book, right, you guys are trying to you invented this word, context is king, right? Attach and associated more context, more meaning into your data, right? So Andy, like the challenge is that it's very easy to say, right? If you ask a newcomer project team, but they will say, how to do it, right? I implemented your entire what you want me to do. I followed the framework. So how to enable this more context, right? Can you explain with example or provide more
context? I give you a couple of things from a context perspective, and I think in the book we also talk about it and provide examples. Context means I want to know which component it is that is emitting the logs, metrics, and traces. So what component to which application does it belong to? In which environment does it run? In which version does it run? Right? If you have multiple components or the same component, multiple versions. And also a big topic is ownership. So which team is responsible for it? And I think these are like 5 things that I mentioned now. And this should be information that every component that runs in your system, every microservice, every pod, every serverless function should have this information. That means what type of component am I? To which larger application or business process do I belong to? In which environment am I running? In which version am I running? And who is responsible in case something fails? Because if you have this information, it opens up a lot of things. For instance, you can see which version of which component runs in which particular environment, what runs in dev, in testing, in production. You can say, is there a difference between version 1 and version 2? You can also say, it seems the latest version in production has an issue. And I also know which team is responsible for it. So I can immediately, because this is a big challenge in operations, finding the right people to then go to, right? And if you have this information enriched, and this is what we talk about, context is king. Now, how can you specify that context? We gave examples in Kubernetes specifically. You can do this through annotations or labels. That means you're putting this on. You can also enforce this very easily. There are policy agents where you can enforce a minimum set of metadata on your deployments. Otherwise, you're not allowed to deploy it. And I also see this, especially in large enterprises, somehow connected with their CMDB, the configuration management database, right, where they have a CMDB tool that contains kind of the service catalog, and there's typically some type of a service ID or an application ID, and that unique ID is then also used on the deployment, so that if you have your observability tool, and the observability tool says, hey, we're monitoring a service here that belongs to application ABC, and then you can go to the CMDB service solution and say, tell me everything you know about this application ABC, and then the CMDB has the information, ownership, environment, version, when was the last change, and all these things.
Yeah, that's a great example. I think like the people who are new to observability, like who they really want to think about how to implement this, I think they can really work on the 5 areas probably you mentioned. And one other thing I want to jump with that context is I think book also talk about like there's a lot of great tooling out there, right? Like there's a lot of tooling to support enabling, enforcing, and guardrails and all the aspects of reliability. But still there's a lot of issues, right? Like I think like every now and then surveys come and say what is still the frequency of major incidents going up, the cost of incidents are going up as well. So what do you think the problem is? Is it like the alert fatigue, or the silos, or missing ownership, or the context? Why? Where do you see the problem?
So it's interesting. I had a discussion yesterday before I jumped on the plane about that same topic. And this company said their traditional approach. So they have teams in their organization that have a very traditional mindset to monitoring, meaning they were setting alerts on every CPU metric of all of their servers and their cluster nodes. And I said, why do you need a CPU alert on a Kubernetes node? This doesn't make sense. Or why do you want to get alerted at 2 o'clock in the morning when some CPU spikes, or when you have a little bit of a memory spike? And they say, well, this is the traditional way we did it. We used to have a couple of servers that grew to maybe 100. And now we have thousands of dynamic instances, and the team that used to do monitoring in the past, they still have the same approach. They want to have these metrics. They want to have the alerts. But now they're getting so many that they say, what this observability tool is not good, right? But the real answer is they are missing the point. The point is, coming back to what I said earlier, I think you as an organization, you should not worry if you have a CPU problem or a memory problem. You should worry if you have a business problem. If your users no longer use your website, if your users are no longer buying on your e-commerce store because either you're not selling the right thing, then the CPU doesn't matter either, right? Or your website is starting to get slow. But slowness doesn't mean it's a CPU spike. Slowness could be a misconfigured database connection. It could be a problem of a third-party vendor that you have. So I think when you start thinking about what I mentioned earlier, if you do observability-driven development, where you start with defining what is the business expectation of a service or an end-user journey, and what are the key technical leading indicators, if you focus on those, you will get a much, much lower amount of incidents, not just alerts, an incident that has a real impact. And if you do this right, that incident also has the right contextual information about what the problem is, what the technical root cause is. Again, it could be a wrong connection to a backend database. It could be a third-party API that starts to fail over because you're running into a rate limit, for instance. These are certain things, and I believe this is also the big difference between monitoring and observability, right? Monitoring, how we used to do it, and I think we explained it in chapter 1. This is not a term that I invented, but the classical, if you have pet names of your servers, if every server has a name, it used to have a name, and you know exactly how it is. But nowadays, this is no longer the reality. The reality is that we are, from an infrastructure perspective, managing hundreds and thousands and 10,000s of different moving components. Doesn't make sense to have these. The good news is, on top of that, we have orchestration layers like Kubernetes, like OpenShift, and other things that automatically take care anyway to provision and reshift workloads based on what the workload needs. So this is why, I mean, the world has changed, right? And for that, your approach and your mental model to monitoring also has to adopt to an observability model.
Yeah. And Andy, I was thinking, right, just to be honest, right, I'm not a good reader when it comes to technical books, right? I kind of it's probably a long time back I used to buy a book or read it, but I actually kind of went through the PDF, and I also browsed your LinkedIn profile, and then I think you were sharing some of these chapters, right, about, and so I came across these 10,000 SLOs and alerts, and then I just search for that chapter. I start reading it, and because it's a problem, right? I had the answer. I just want to double check, whether you guys are going into the same the end. Then it hit me, right? Some of the technical questions I can ask from ChatGPT, right? How to do it, how to implement, do a comparison, right? It's probably 5 minutes job, right? So what I realize is that I should read the book, because it's a mindset change, right? It's not about the technical stuff, right? That's the easy things, right? But it's about having that correct mindset, having that framework, understanding why we are doing that. The why part is more important. And I felt you guys are probably, with the technical book, we are expecting so much of technical content, but while you are addressing that need, but it's all about trying to set the mindset, right? Is it?
Yeah, it's a good way. Thank you so much for it's a perfect summary. Yeah, exactly. Because it's the technology that we're using today has completely transformed over the last, every decade. There's obviously a complete different change, and we like technology changes. Technology changes also give us new opportunities, and we need to rethink architecture. So, for instance, if you think back when we moved to the cloud, and many people started doing a lift and shift. The lift and shift doesn't give you any advantages of the cloud, because if your architecture was not in a way that you could leverage dynamic elastic scaling, then your monolith on an EC2 instance is still just a monolith that cannot scale. So moving into cloud and into cloud native really allowed us and forced us to think about new architectural models that really allow us to leverage the dynamic scalability of the cloud. And the same is true with monitoring and observability, right? It's a different world. It's a different architecture we have, and therefore we also need a different approach to observability. We cannot just monitor 5 hosts or 5 services that are now 5,000 hosts and 5,000 services and believe on every service we need to define 2 SLOs. This is where the number 10,000 comes from. This was a real example from conversations I had. Somebody said, I need to specify 10,000 SLOs. And I said, why? Why do you want to define 10,000 SLOs? Who is going to define the thresholds? Who is going to maintain them? Do you have 10,000 runbooks? Meaning, what happens when one of these SLOs fails? And then in conversations, it came out that they were just using an old mental model and were defining SLOs on every single endpoint, on every single service, on CPU throughput, memory consumption, and this didn't make sense, right? So this is why we then changed the conversation to what is the business problem you're solving? How can we monitor if the business is successful? What are some of the technical leading indicators? I always go back to this. What is the business? And what are technical leading indicators? So a technical leading indicator could be you have a critical queue in the back, a critical database. You have a critical central service. And if you know if this is getting slower, if the queue is filling up, if the database starts to have problems because the index is out of date, then you know this starts to become unhealthy from a technical perspective. And if you don't act now, it will have an impact on your business. Right, and this is the mental change. That's really what it is.
Yeah, absolutely. I think that once you have that change, you can really develop scaling, high performing systems, right? I think that's the secret. So I will so I think the one of the other summary statement I took it from the book is that you guys think it's about intelligent alerting, right? Like be smart about, like you always go back, right? What the business wants, think about what's good for business. So it's that intelligent alert, and then figuring out why it has happened, right? Root cause, and probably fixing part, right? Resolution. So based on your experience at Dynatrace, talking to all the customers, and probably I'm sure you do a lot of research for your book as well. So where the AI is currently doing really good, and where probably it's behind and probably improve in future?
So the AI can only do good in situations where a human would also do good. I mean, the AI will be faster, right? But to give you an example, right? If you have an observability setup where you have, from the very beginning, where we say you have an organization with 10 different observability tools, a human needs to do a lot of work and needs to learn a lot of different tools and a lot of different languages for these tools, like query languages, to get the information and then correlate it. The AI will produce faster a result, but the AI also has to do multiple steps in a very inefficient way. I think the power of the AI will come in, and from an observability perspective, if the observability data has the right quality, the right context, ideally everything is in a single place and not distributed across multiple systems where you need to query massive amounts of data, taking it out of context and then putting it together somewhere. So ideally, when you have a system that has high quality context and rich observability data, it will be easier for the human, and it will supercharge an AI, because then the AI can not only produce a fast result, but it also can do it in a much more efficient, especially cost efficient way. And it will also most likely be much more accurate because it doesn't have to take guesses, right? You mentioned earlier, we moved from a deterministic to a probabilistic or undeterministic model. The better the data, the less chance of the AI to hallucinate, because it doesn't need to guess anymore.
Yeah, absolutely. And so when the teams adapt, right, they want to go through this journey, right? What should be the first thing they should do? I think you have, probably I'm asking the repeat question. So what they should do, right? Where's the focus, right? It's getting the business requirement first. Is that what they should focus?
I think that's the mental change, definitely, right? You need to ask the right questions internally, right? You need to ask the question is, do we know what the expectation of this system is? Do we know how we can measure it? do we know what information we need in case something doesn't go as expected? Right? I think that these are the right questions to answer. And then you also need to start with, obviously, you need to then figure out a way how at scale, consistently, you can really monitor all of your systems. Because in the end, once you have solved the mental questions, you still need to go back and say, okay, how do we technically implement this now? That means, do we use OpenTelemetry? How do we get the logs? How do we get the How do we get the traces? How do we get the metrics? What are we standardizing on the minimum set of context? Where do we send the data to? Right? Do we send the data to an open source backend that is self-hosted, or do we go with one of the vendors like Dynatrace? These are then some technical questions. But the thing is, right? I believe, if you don't have this mental shift, you will fail, independent of which tools you are going to pick. Because in the end, right, there's many great tools out there, but if you're not using it correctly, or if you're trying to solve a problem and you don't really understand the problem, if you haven't figured out a way what problem you really need to solve, then you will also use these tools incorrectly. And then what I've seen, right, especially when people sign contracts with tool vendors, and then the renewal comes up, then typically the question is, did we get value? And then often they say, we don't even know what value it provides. And that's an indicator that they don't really know how to do observability correctly. Right? Because if you sit down and say, our goal is that our business runs successfully, and right now we can monitor when it's not successful, and we know in 10% of the time we have a problem, and now we have implemented new best practices, and now we use a tool that tells us when a problem happens. We can now find better the root cause, and then you can say, after a year we've cut the number of problems in half, and we're much faster in reacting. We talk about MTTR, mean time to respond. And then these are metrics that you can say, hey, we've invested in observability. We're using, let's say, Dynatrace, and in the last year or two, we have reduced the number of problems by 50%, and we are 50% faster in responding, not only because we implemented Dynatrace, but we have a new approach to observability.
Yeah, absolutely. And so, Andy, I think we are into the last leg of our podcast, and I want to really get into some interesting stuff as well. So, just to tell me, I have a couple of agents. I actually given them a couple of names. They do white coding for me, and it's going great, right? Those are some side projects which I'm really passionate, where I didn't have much time, but now agents have time, right? I just have to give them direction. So it's all about vibe coding, right?
And you have to give them the tokens, obviously. You need to give them the tokens too. It's not for free.
Yeah, absolutely. But there's a solution, right? Probably you can host a open source LMM like Llama, and just it's a little slow, but it will still do, right? So I listened to one of your podcasts, right? You talk about one of your friend who has vibe coded the entire product out, which is doing great, and the productivity is 10x, it's multiplying, right? And those people like that, right? There are also a lot of people who say vibe coding is bad. There's a lot of unknowns. Agents are doing things, which we don't have much control. And if you look at both sides, right? I think you've written a chapter called Observability Agent, right? In the agentic world, how observability agents and that concepts will try to, because if you really look at it, vibe coding is not going anywhere, right? It will, I think, amplify, right? It's just that observability agent will improve to support it, right? Probably if there's something lacking in the vibe coding side, agent will do those things to support, right? So what do you think, right? In that chapter, can you take that chapter and try to bridge it, right? What do you think, still vibe coding will go on, and then observability improve to catch all those failures, be that guardrail and be that support? So it's not 10x, right? It will even 100, right? What do you think?
Yeah, I think I have two answers to this. The first thing is like with a human, right? If I'm not talking about an agent, but if I go to a human coder, I need to give that human coder very good instructions. The better instructions I give it, the more I better explain what I want, the better the output will be. And this is the same with an agent, right? So this is why I think it's very important to give enough context and explanation. The second thing that is very important, this is feedback. People learn from feedback. I, as a developer, I learn when I build something and I run it and I test it and I see I have 50 new exceptions that I've never seen before. Oh, where do these exceptions come from? Oh, there's a config mistake. I missed something. And so I learn and iterate and become better. And the same is true for agents with observability. So one aspect of observability for AI is that we provide a very close feedback loop back to the coding agent to show that agent what the impact actually is of their code changes. And with that, the agent can also learn and say, hey, I made the code change. Functionally, everything is correct. But now I've introduced a 30% memory increase, or I have introduced more round trips to the database, which might be intentional, but if not, it's a problem because it will kill you later on. So, right, I think on the one side, observability needs to be a closed feedback loop to the agent to learn from every single step and to improve the quality of the code that is getting out. We also talk about observability in the book, in the observability agent. This was also where we can really develop an agent that uses observability to help you in your production. So this is kind of like the AI ops use case. In case a problem happens, then an agent can kick in, having automated access to your observability data. So the agent kind of like being the observability expert. And I nowadays when I give presentations, I typically say, I'm Andy. I have 18 years of experience in looking at logs, metrics, and traces. This is great, but I don't scale. But what I can do is I can write my knowledge, my best practices, my approaches down in an agent file or in skills, in prompts. And then all of a sudden, there's an Andy version of me, or there's an agent version of me that can then basically automate my experience, what I would normally do. So there's different aspects of this, but close feedback loops is very important. Using observability to learn, to improve, to act on.
Okay, that's great. I think that's a really the interesting part. I think because vibe coding is really not going anywhere. I think like how quickly they can adapt into these concepts really help them to ensure that they don't create a lot of technical debt, right? I think that's the whole idea. The last part, right? Last few questions in the book, right? Like I know, right? I watched a video like your co-author is Hillary. And you guys are talking about, not going to write a book again, right? I think you were saying you will not write a book again, right? Yes. So, but I know, like, but if you had to write this book again, right, after like probably 6 months, 12 months, right? What you will change? What different it will be?
That's a good question because actually many people asked us, why do you write a book on a topic that is changing so rapidly right now? And I think Hillary phrased it really, really well. We really tried to write a book that is agnostic to time because we write a lot of best practices that I think will still be relevant even as AI is changing a lot of things. But all the best practices we just talked about, all of the think about the business and the technical indicators. Think about context. Think about use cases where AI can help you. I think this will maybe the model that you're using and some of the workflows might be different, the agentic workflows, but the general concepts I think will be relevant and correct as we wrote them for a little while longer. However, right? Who knows? Maybe something completely revolutionized, something again happens this year where we say, wow, we need to rewrite complete chapters, but I don't think so. I think we really try to write this book with best practices that will have relevancy and are valid for more than a couple of months.
Absolutely. I think like it's a philosophy, right? I think you guys were trying to reach out to that philosophy and that underline as you said, the concepts which will never change, right? Like there will be slight deviations here and there, but the fundamental thing will stand, right?
Exactly.
So the last question, Andy, I know, like, you are very passionate about what you do, right? Like, when I go there, you are linking all about traveling, what you share with your community. So, I see like there are three type of audience, like, who's watching my videos, like, who's trying to get into this work, who are kind of like, doing this work, and then developers, right? Trying to figure out like, what's the new thing, right? But generally what I've seen is that observability has really evolved during last 5-6 years. There are careers, right, on top of observability. They just focus on observability. Their day job is observability, right? So with this AI changing, right, like, now deploying a tool is not that uh, difficult, right? Dynatrace, one agent. Agents are doing all the hard work, right? Root causes, everything, right? So if someone is in this observability career, right? And I know, right, like, you think like, still go back, figure out the business, all those things, but reality, right? What do you want them to learn? If they think that, okay, if I'm using Dynatrace, probably I have a job now, but maybe 6 months, 12 months down the line, Dynatrace will do everything. Maybe I don't need Dynatrace, don't need a human to do it, right? Maybe work with the BAs, business stakeholders, figure out that the business aspects, and then automatically deploy this, right? So what they should do, right? People who make a living out of observability, what is your advice for them?
Yeah, I would say it's the same advice that I would give a software engineer that starts new. Even though vibe coding will, or agents will take away the writing the code itself, I think you need to understand the fundamental concepts of software engineering, how systems behave. I think and that's also true for observability. I think what helped me a lot, and that's what I can encourage everybody to do, is really learn the basics and seeing how do distributed systems behave, where do systems typically break, what are different types of architectures, why are certain architectural decisions being made, why are they not made, because eventually you will end up analyzing and being responsible for systems where you cannot, where if you've never thought about that a concept of a thread pool, a connection pool, could actually have an impact in scalability and resiliency. If you don't know that if you have multiple systems connecting to each other and you have different types of timeouts set, different types of pool sizes set, that this will eventually result in an unbalanced system, and therefore the system will break. I think as somebody that starts in observability or wants to make a career, you need to understand the fundamentals of distributed systems. You need to understand the fundamentals still of logs, traces, and metrics and events, because you will still work with this, right? Even though maybe the AI helps you a lot, but in the end, it's about understanding the fundamentals, and why certain things are done, why certain things are not done. Also learn from the past. There's a lot of great examples out there, a lot of great literature on these topics. Read up on modern software architectures. So that's what I would do.
Yeah, and one thing that clicked me is that in one of the videos, Hillary mentioned she even go back and read about design patterns, right? Like, very all big about design patterns.
Yeah,
so
exactly.
so I recommend everyone that, like, maybe you give a try about the book Andy and her colleagues have written, because it captures the essence of observability, why we need observability, best practices of observability, and if you think that that's going to get outdated, they already enable it to the AI native world. And with this new era, how to survive, how to build a reliable, resilient systems. So, any last comments for our audience, Andy?
No, I think just stay curious, keep learning, and don't think just because we have now a new tool that's called AI that we don't need to know the basics. I think it's it's the same with if you drive a car and you get used to the beeping noise when you try to back in reverse. If you're getting used to that, and all of a sudden you have a car where this thing doesn't work anymore, you still need to find a parking lot, and therefore it really helps if you still remember how to measure distance without having to rely on a sensor. And so I think it's maybe a strange analogy, but it's still an analogy. So we want to make sure that we're not unlearning things completely.
Yeah, that's great, Andy. Like, it was a pleasure talking to you. Like, I think almost 1 hour.
Yeah.
It was really interesting stuff, and I think like there's so many things interesting inside the book, right? I think that's what we recommend everyone just go through it, grab a copy, read it, and hopefully if they have comments, they can find you in LinkedIn. And
Yeah,
I
exactly.
recommend everyone to follow you in as well. Like it's just
Thank you.
easiest way to get up to date, right? Like you
Yeah,
manage to send posts like every other day. So
exactly. Yeah, yeah.
so
That's my
thank you.
my normal channel. Yeah.
Yeah, absolutely. So thank you so much, right? Thank you very much for spending this time during your busy schedule. I know you came from Canada, and you must be very tired as well. So thank you so much.
Thank you.
Wish you good luck for the book as well. I hope that it's going to get great success, and that success will, yeah. And I hope that that will kind of like trigger you to write your next book as well.
Yeah, we'll see about that.
Thank you again, Andy.
Thank you. All the best.